find the cross product, I'm going to write it as that 3 by 3 determinant first. First row, always ijk. The second row will be the coefficients of the first vector in the cross product, in this case a. So we were given already a in component form, so I'm just going to copy down what those coefficients were. So a 4, a 3, and a 12. The third row is going to be the components of my second vector, in this case it's b, and those components are -2, +5, and -14. And we're dealing with things with units here. I find it helpful to remember to write down what those units were, because later we want our result to have the correct units. All right, so we made our 3 by 3 determinant. Now we can expand that into its cofactors. So it will be a cofactor times I minus a cofactor times j plus a cofactor times k. So we have to determine what to put into these cofactors. What are these 2 by 2 determinants? And for that, we look at what is the vector we're multiplying it by. So if we look at the I, the stuff that goes in here is everything that is not in column I and not in the row that has I in it either. So if we cover up this, we cover up that row. These numbers that remain are what go into this cofactor. With j, again, we cover up the column j is in and the row j is in, and write down everything that's left. We have a 4, we have a 12, a -2, and a -14. And with k, if we cover up its row and column, we're left with 4, 3, -2, 5. So we have 3 2 by 2 determinants now. These now we can expand using the rule for 2 by 2 determinants. Upper left times bottom right minus upper right times bottom left. And this is where you really want to be careful with the signs you have on all of the entries, because there's going to be a lot of negatives floating around. This will be 3 times a -14 minus a 12 times a 5 times I hat minus 4 times -14 minus 12 times a -2 times j hat. Again, this whole thing, that's negative. Plus 4 times 5 minus 3 times -2 k. Simplifying these is just arithmetic, so I'm going to have a single number in front of I. That's going to come out to -102i plus 32j plus 26k. And then this will have units associated with it. Like with dot product, the units are going to be the product of the units of the two vectors that we were inputting. A was in newtons, B was in meters, so our answer is going to be in Newton meters. N hat is defined as just the direction normal to our two input vectors. To find n hat, what we first need to know is a vector that is perpendicular to both of our input vectors, which very conveniently we just found. A cross B gives us one such vector. But n is a unit vector, as indicated by the pointy hat on it. So we want to take this vector and normalize it, so we can divide it by its own magnitude. We just found A cross B was -102i plus 32j plus 26k. And the magnitude we find by, just like we've done magnitudes in the past, square root of the sum of the squares. The magnitude of A cross B as we found it is 110. So the unit vector that's normal to both of these vectors, we just take this and divide everything by 110. So the unit vector is negative 0.927i plus 0.291j plus 0.236k. Final piece, part 3, and this is actually easy. We want to find B cross A. There's the hard way to do it, which would be doing the same process we just did again in part 1. But what is a faster way to find B cross A? Right, it's just the negative of A cross B. Well, we in part 1 found that, so we just have to take its negative. So 102i minus 32j minus 26k Newton meters.